So today I'll be talking on the topic called onboard diagnostics. But before that, I would like to show some of the video related to the lubrication as well. I have not shown last class. I would like to show some of the videos. Then I will go with the onboard diagnostics. Uh, if in case you are not able to hear or see the video, you just WhatsApp me so that you can WhatsApp me. You can able to see the video in WhatsApp. If in case if you are not able to see, I will try to do it again. Just give me a WhatsApp message that you can able to see it. So now here now we are going to see the lubrication system in automobile. You can also WhatsApp me like you can able to see it. Hello. At least somebody can message me that we can able to see it. Okay. Thank you. Okay. So again, whatever I have covered the previous class, again I'm going to give you a thing with respect to the lubrication system. So in automobile, we use the lubrication system basically to reduce the friction between the two contact and relative parts, which is basically moving each other. And we also use the cooling to make sure that the heat getting generated away, getting generated, whatever is getting generated by the because of friction, that gets cooled. Okay, so this is the main reason why you are going for this lubrication. And we have the different types of lubrication system. First one is the mist lubrication system, and another one is wet sump lubrication system, dry sump lubrication system. This wet sump lubrication system is divided into three types: splash system, splash pressure lubrication system, and full pressure system. I have also uploaded this the document PPT. You can also see the importers backpack. So this wet sump is very much important. To explain that as well. So first we are going to see about the mist lubrication system. We are going to use this mostly in the two-stroke engine rather than going for a four-stroke engine. Okay. Uh, here, here in the case of mist lubrication, we are going to use a sump, basically oil sump, which will be below the crank or crankshaft, what we call, and here this is mostly applicable for a two-stroke, and there is some limitation also is there in the case of mist lubrication system, which can be overcome with the help of the wet sump what we are going to see. This is the oil which will be below the crank, okay, and this will be stored at the bottommost layer. And two-stroke, it is basically for a two-stroke, and this will also ensure that the engine oil is not going to get mixed with the engine and the fuel basically. So again, when oil is going to mix with the fuel, then what happens? It gets a foamy kind of thing you get, and again, it will also lead to some the smoke kind of thing as well. Okay, so you need to avoid that, and for which this mist lubrication will help in the case of a two-stroke engine. But there will not be any pressure like to lubricate the parts. There will not be any pressure in the case of mist lubrication system. But in the case of wet sump, what we have is we have a splash kind of thing which will strike the moving parts or a friction where we are going to get a friction with the help of a splash system with pressure as well. You have three type of system in the case of jet sump. One is splash lubrication system, splash pressure lubrication system, and full pressure lubrication system. So you have three types, and here in the case of jet sump, what happens is you have the larger capacity of oil tank, basically sump, whereas in the case of two-stroke, the sump capacity is lesser. But here the sump capacity will be higher. Uh, uh, this system is having the larger capacity, and what I have also explained. So this is the place where you are going to have the sump, the lubrication system. This is where the lubrication oil is there. So the capacity is going to be higher. You have the oil pump, and we have also seen in the last class that how the oil is going to get circulated from the tank to the lubrication parts like the tank shaft, then, and then to the camshaft valve spring. Again, how it is coming back again to the oil sump. Okay. So you also have the oil cooler, which will reduce the temperature of oil because whatever the oil which is coming out, which is coming again to the sump after lubricating the parts, the temperature will be going to be higher. Again, you cannot use the same oil temperature to lubricate the friction parts or the moving parts. So you need to have the oil cooler to reduce the oil temperature further. And that reduce the oil temperature, oil will be going to the different moving parts to generate whatever the heat is going to get generated. It gets carried away, and it will help for reducing the temperature. Okay. Then for the first one is the splash lubrication system, where you have system where the oil gets carried away, and you have the scoop here. Basically, the scoop is nothing but the jet kind of thing, okay, where the oil comes out through the scoop. You see, this is how the oil gets moved away to a different location of the crankshaft. And basically, the bearing area also it goes crankshaft bearing area, crankshaft, and also even to the cam bearing area, camshaft, valves, valve spring, etc. And again, whatever the oil is getting carried away, again it comes back to the oil sump again. And the next important thing is the next system called the flash and pressure. The last thing you have the scoop where it gets splashed away. But here, not only the splashing, but again, splashing is nothing but a spraying kind of thing. Just it just sprayed. But the spraying will happen with some pressure again here. So what happens? The advantage of this is it will help for the better efficiency, and even the high speed engines or the high efficiency can be obtained with the help of this plus pressure lubrication system. You have the last one type called only the pressure or full pressure lubrication system, where it is mostly for only for the splashing point of view as well. Only for a full pressure, okay? Like you don't have the splash pressure, but it's completely a pressure kind of thing. Even for the race cars, go for this type of thing, like where the temperature will be too high because of the high speed of the engine, where you need to completely have the pressure to lubricate it. Okay, you can prefer that in the case of a race car. This is still quite good. But in most of our vehicle, we have both flash plus pressure. Depends on the configuration of the vehicle as well. So you have the oil sump and you have the oil filter which gets filtered and it goes to the main oil gallery to the top of the oil pump. And then it is the pipeline or the region how the oil goes to the crankshaft, crank web, and also the crank bearing. And again, we have also seen the last class video how oil gets going to the different parts like camshaft, valve train, and then how it is again coming back to the oil sump. We also have seen that we have an oil cooler before it is going to the main oil gallery. Before it is going to the main oil gallery, the temperature of the oil gets reduced with the help of the oil cooler as well. So the last one is the dry sump lubrication system, where you have the oil sump, where the oil gets stored away at the bottommost portion. Here, what is the difference is that you have a separate reservoir, whereas in the case of the wet sump or in the case of the mist, you don't have the separate reservoir. Whereas here you have the reservoir, separate reservoir, and then the oil comes to the oil sump through the reservoir with the help of a scavenging pump, and whatever the used oil from the engine parts, it again comes back to the oil reservoir again. Whenever it is required, it again goes there. Okay, so here it adds additional space basically. It adds additional space, and it may not be required. But the one more advantage is that if the temperature is going to be too higher, and even if you do not have the, if in case there is any fault with respect to the oil filter and the oil cooler, then what happens is this the reservoir, whatever it is having the oil having the temperature maintained. Okay, that oil when it is mixing with the heated oil, the overall oil temperature gets reduced or compensated, and again that can be used for the recirculation. But this adds additional weight as well as additional space. Uh, Basically, this we can avoid it, but the most preferable one is the wet sump, and in which we have three systems. And even mist is applicable only for a two-stroke engine, where the space will be very much lesser. Even the two-stroke is not been much applicable for the wet sump as well. So now we see how the engine cooling system works with respect to the automobile. So we take an example of a car engine. Okay. So it is basically an internal combustion engine where the power is getting generated based on the expansion of high temperature and pressure gases. So here, you're going to get heat due to the combustion of gases, and also you're also going to get the friction of the mechanical parts, for which to reduce the heat, whatever is going to get carried away, and also because of the friction, you need to reduce the temperature as well as the friction, for which you need to have the cooling. And for sustained operations, you need to have the excess heat, which should be removed to maintain the temperature, for which the cooling system is very much important. We have different parts of cooling system. So we will see what are the parts that we have for the cooling system. So this five is very much important. The water pump, radiator, we have seen the radiator last classes, the thermostat, and we also have the sensors to ensure that temperature is going to maintain. We need to have a coolant temperature sensor to ensure that temperature is not going to higher. Means it will give you an alarm basically. And you have the coolant. Basically, the coolant is not pure water, but water plus ethylene glycol. Basically, you are going to add ethylene glycol, which is acting as a antifreeze agent. Why? Because the boiling point of your water is 100 degrees Celsius. Suppose if the coolant temperature is going beyond 100 degree, you're going to experience the bubble decay of water. But when you go for a ethylene glycol, where the boiling point can even though the temperature of the coolant what you're going to use is going to be higher than 100 degree. So there in some cases it can go up to 120 degree also in the worst case. Okay, but the nominally the range what you should have is 110 degree. That may sometimes 120 degree also may be possible. So if that is the case, then if you're using only water, what happens is the boiling point of water, as I said, is going to be 100 degrees Celsius. You're going to experience a lot of bubbles that again will create a problem. So that's why you need to have ethylene glycol as one of the antifreeze agents, for which you need to have 50% of water along with 50% of ethylene glycol. So it will act as a coolant. So first you will see the water pump. You pump the coolant basically. So water is nothing here. Water pump, as the name indicates, the water pump. Here we are not going to pump only the water. The water plus ethylene glycol, which is nothing but a coolant. Okay. So it's nothing but a coolant pump. It's not only the water. Okay. It's like so you should make ensure that the water pump is not it's been applicable basically for a coolant point of view. This is the it should be the heart of the cooling system which pumps the coolant. It is not going to pump the water, going to pump the coolant. Okay? Coolant consists of water plus ethylene glycol. So I have told you why you are going for the water along with the ethylene glycol. So it is different parts basically. It is having the impeller, this impeller. It is also a pulley flange. Okay. Again, a O-ring will be there to reduce to avoid any sealing issues. Okay. The impeller is driven by the engine, and you have the next one called a radiator. This is quite known to everybody. The purpose of the radiator is to exchange the heat used for transferring the excess heat, which is developed by the atmosphere to by the engine to atmosphere. So it is having a air which strikes the radiator, and again the coolant, whatever it is, coolant will come at the topmost position, will come and again with some temperature called, say for example, x degree. When it is going out, the temperature will be much more lesser, which is required again to make sure that it is going to get recirculated to the engine. It is having the inlet port and outlet port, and again it is also having the drain plug. Um, See again, you have the pressure cap also as a part of radiator. And, you have the brass tube basically. The radiator is made up of the brass tube. You have different configuration depending upon the heat conductivity. You can select a material as well. And the next important thing is the thermostat. Okay, so it is a valve which regulates the flow of oil and coolant. And see, when the temperature of the thermostat is going to be lesser than 92 degree or 90 degree, what happens is it will not open. Okay, it will open only when the temperature is beyond 90 degrees Celsius. When it is below 90 degrees Celsius, uh, the coolant will pass through the bypass and again it goes to the engine, basically engine cylinders, etc. But when the temperature is beyond 90 degree, I told you, the coolant enters the radiator from the top, so the thermostat will allow the coolant to enter into the top portion of the radiator. Temperature is going to be higher than 90 degrees Celsius. It is having the frame. This is how the looks frame. It is having the cylinder. It is having the cylinder, and it is having the spring. It is having the valve, main valve, basically. These are all the parts that you have for a thermostat. You also have the bypass valve. So when the temperature is going to be higher than 90 degree, the main valve will open and the coolant goes to the radiator, and when the temperature is going to be lesser, then the bypass valve will open and it will not go to the radiator, basically. You also have the sanitary spring here. You have two springs. So you have the coolant temperature sensors as well. Yes, I'm getting some WhatsApp. Just a minute. If in case it is not audible, but no sound. Oh, you are not getting any sound? Whether my voice is audible? Uh, okay, thank you. Thanks for the confirmation. Okay. It's very much important to ensure. Otherwise, okay, you also have the okay. Okay. So you have the the coolant temperature sensors, basically to sense the temperature. Basically, you have the sensing probe, which is connected to an electrical connector that will help you to understand what is the temperature. I told you you have the temperature range. Based on the temperature range, the thermostat valve will open and close, for which this will give you the alarm as well, or give you the signal. Uh, so see here, you need to have the coolant for all the moving parts, basically. You have different moving parts in an engine, and again, you should ensure that this cooling is going to be proper and it's going to be much more safer without affecting the mixing up of the oil along with the coolant. Okay, even this oil should not get mixed with the coolant, apart from the oil mixing with the fuel. Okay, so even you will get some kind of problem when this coolant is going to get mixed with oil. Okay? So this also a very challenging task to ensure that you are not going to mix the oil with the fuel and again oil with coolant as well. So you have the radial controller through which the water pump pumps through the system. It is driven by help of a separate belt. We also have the belt. This is a belt. You call this belt as a separate belt. It also helps. This water pump will also get drive along with the power steering pump as well. So you have the bypass valve. I told you the temperature is not going to meet. You have the coolant will not go to the radiator. It will right straight away go to the engine. So you have different parts like water pump inlet, outlet, the radiator up and down, and this is the cooling tank or the degassing tank we call, where where the ethylene glycol plus water get mixed. We also have the coolant overflows. Now we'll see how this is getting working. It's a thermostat and it regulate the flow of the coolant. See, this is how the coolant gets filled away with the help of thermostat valve. And you have the bypass valve open and bypass valve closed. The bypass valve open when the temperature is lesser than 90 degree, and will open when it is higher than, sorry, less than 90 and higher than 90. So here they mention is 90 in Fahrenheit. What I told you, 90 degrees is in terms of degrees Celsius. This is the radiator bottom portion. This is the radiator top portion, and from the bottom portion it goes to the engine, and from the top portion it goes to the thermostat valve, and thermostat valve it will open when temperature is more than 90 degree. It goes to the radiator, and with the help of the heat exchanging process along with the air, temperature gets reduced, and again it comes back to the engine. So you have the coolant temperature sensor as well to ensure that the temperature monitoring is going to happen continuously. So this is how the air, when it is striking the coolant, is going inside the radiator tubes. The hot coolant means the heat exchanging will happen, wherein the hot coolant will become the temperature of the coolant gets reduced, and again the air which is coming out will be hot. Okay, so incoming air will be less, will be cool, and when after striking this, the temperature of the air will be higher. It also builds a pressure inside the system as well. So we also need to maintain the pressure. When you see when the pressure is going exceeding, what happens is there is a possibility that you have a pressure valve, pressure cap basically, that will also open when the temperature inside the system is going to be higher. Because of high pressure, what happens? It will also push the pressure cap valve to open. You should maintain that it should be, it's not go beyond 15 psi in terms of pressure value. We have the degassing tank here. It's basically a cooling tank. Stores the ethylene glycol with water for 50% each. And again, the capacity of this is based on the design requirement. It will vary from configuration of engine to other thing. Then we also have the heater system, which consists of hoses, and again you also have the heater core to ensure that whatever the hot coolant is going to, before going to the okay. So in a normal engine, what happens is the total heat which is produced by the combustion is used to push the piston downward up, and it will also produce the necessary power. So here, whatever the heat which you are going to get out of the combustion, that comes as a hot exhaust gas, and like the walls become hot. So all this heating means whatever the parts which is going to get heated with the help of because of the combustion. So it needs to get cooled. That is possible with the help of a coolant. You see here the main purpose is the heat of the engine is absorbed by the coolant in order to bring the engine temperature within the normal operating range. So it is what we have seen in the last video also, but now it is having a different view. Like you have the radiator, this is the radiator fan, and you have the water pump in this location. You have the thermostat, and you have the coolant reservoir or a degassing tank, and you have the heater core. Okay. Okay. You see here, when the engine is getting started, the water pump connects it, and I told you this water pump is connected with the help of the belt is connected to the power steering pump. Once it starts, what happens is it begins to pump the coolant around the engine cylinder from the lower radiator tank into the coolant passage. Okay, so this is the lower radiator tank. Okay, this is the radiator. This is the lower radiator tank, and the coolant comes from this portion. It goes to the engine cylinder, and this is possible with the help of a water pump. You see the dotted one. Okay, so all these are the coolant. Okay, the dotted one, the green color, is nothing but the coolant, and this is the coolant passage. The flow of coolant is from the lower tank to the engine block, then to the cylinder head. It comes to the engine block first, then it goes to the cylinder head, and finally it goes to the outlet of the radiator. The outlet for the radiator, which means it comes again to the radiator. And whatever the before it goes to the radiator, what happens is before it comes again to the radiator, you need to ensure that the temperature, what I said, is be higher. And if the temperature is lesser, what happens? It will not go to the radiator. It will come back. The help of the bypass valve again goes to the recirculation mode. See here, the coolant, what it will do is that it begins to absorb the heat which is produced because of the combustion process, and the heat is being carried away by the coolant, which is getting expelled with the help of all the moving parts. We have a thermostat, so it is very much important. Here, basically, it should be 90 degree for most of the car application. Uh, it restricts the coolant flow towards the radiator when the temperature is not going to be higher. And when the temperature is going to be lesser than that, what happens? You go to the bypass valve, and again that goes to the engine cylinders. So you have the radiator core, the heater core. As I said, when the temperature is going to be lesser than the specified limit, what happens is it also goes to the heater core. With the help of that, the heater core, even the temperature, whatever it is, still get reduced. And from there it comes to the engine cylinder with the help of the bypass hose. We have the blower here. It's like similar to that act as a mini radiator, the heater core. It is used to transfer the heat from the coolant to the air that flows inside the passenger compartment, basically. So you have a thermostat on the other hand, which acts as a regulating valve to control the coolant flow into the radiator, and it also maintain the engine temperature within the optimum range. So this is what I have seen. We have also explained to you the last video. It consists of the primary spring, secondary spring, the rod, Basically, it should be the Fahrenheit. If you say a 180-degree Fahrenheit, the wax, design the wax, it will begin to melt. Uh, you also have the fan, radiator fan, which will also rotate continuously once the coolant flows outside the thermostat into the radiator, basically. We also have the pressure regulating cap or a pressure cap. Mm, what happens because of the high temperature of the coolant, there are also a possibility of building up high pressure that might also block the coolant from entering the upper tank. This is the upper tank, okay, and again, this high pressure, what happens, should be lesser than 15 psi. Okay, if it is going beyond that, it will vary again. The pressure will also vary with respect to engine configuration. And see, if it is beyond the 15 psi, the pressure whatever is going to get built away, you will ensure that will make the pressure gap to burst basically. So it's again the recommended value you need to maintain to ensure that it is not going beyond the high pressure value. See, if in case if this gets open, it will also go to the reservoir. Okay, like even by even though if it opens also, you have the protection. Okay. See, this is how the radiator flow from top to bottom. You have the tubes, basically made up of different material. You have the brass tubes. You also have the aluminum tubes, but here for a better heat transfer rate, you're going for the brass tube kind of thing. Um, you're going to have the heat transfer with help of the fins. These are the fins. So one side the air goes, on the side the air is nothing but the air and the flow of the coolant. And when the coolant is going to reach a lower portion of the radiator, the temperature of the coolant gets reduced considerably because of the air which is having the lesser temperature will cool the coolant. And again, it is getting recirculated from the lower. See, this is how the DLC pin looks. So CAN stands for uh, Controller Area Network. The DLC stands for Data Link Connector. This is the location where you normally put your onboard diagnostics, where you connect it. The location will vary, but mostly it is located near to the foot of the driver. Yeah, this is the code actually. Diagnostic trouble code. This is a structure how it looks. It's basically a 5-digit number. The first digit is basically for a system, like if it is related to body, it starts with B, AC starts with C, power tank starts with P, and if it is something related to network, you get P. And the different names will have numbers will have different thing. Like if it is zero starting, then it can be it say for example P0101 is related to the mass or the volume air flow rate. Okay, so similar to this, you have different codes for different issues of the vehicle. I told you, even if you get some of the knocking or detonation, okay, sometimes you may get some noise in your engine, okay, but you may not be knowing whether that noise is normal or not. Is it a knocking noise, or is it a detonation, or is it a normal noise, okay? And sometimes you also do not know whether the engine is getting misfired or not. So those things can be found out with the help of by connecting that tool called diagnostic tool. And you can also connect it with the help of a scanner, and you can also even connect it to your mobile. And using ER, but the thing is that you need to enter this code, and according to that code, you will get the whether the vehicle is having the fault in the particular code or not. If it is having the fault, it will also give you the solution. Okay, solution in the sense change the coolant, or add increase the level of a fuel, or increase the level of oil, coolant, change the sensors, change the hoses. Okay, so all this information you can get it based on the communication what you're going to get. Okay, so what I will do is that I will upload this document today, um, and then just you can have it for your reference. Uh, and maybe meanwhile I will see how I can cover this topic. Okay, thank you, and you can contact me in WhatsApp or in call in case any doubt if you have.